Close your eyes for a moment. Imagine you are floating in the deep, freezing darkness of the outer solar system. Far away from the warmth of the sun, a pale, ghostly blue sphere hangs in the void. For decades, we looked at this world and saw nothing but a quiet, frozen, featureless ocean of gas. We thought it was a sleeping giant. We thought it was boring. But the universe has a funny way of proving us wrong. NASA has just turned its most powerful instruments toward the seventh planet from the Sun, and what they found changes absolutely everything. Welcome to the new reality of Uranus, a world of glowing rings, hidden oceans, chaotic magnetic fields, and diamond rain. Take a deep breath. Let the silence of space wrap around you. Tonight, we are going on a journey to a planet that has been keeping secrets for billions of years. Let us see what NASA just saw. To understand the sheer magnitude of these new discoveries, we have to travel back in time. The year was 1986. Humanity was pushing the boundaries of exploration, sending a tiny, fragile mechanical emissary called Voyager 2 into the unknown. When Voyager 2 flew past Uranus, it sent back images that left scientists slightly disappointed. It looked like a smooth, pale blue billiard ball. There were no swirling storms like Jupiter. There were no grand, sweeping rings like Saturn. It was just a calm, aquamarine sphere. For nearly 40 years, this single, fleeting encounter shaped our entire understanding of the ice giant. We built our textbooks, our models, and our theories on those few hours of data. But there was a ghost in the machine, a cosmic coincidence that skewed our vision. We didn't know it then, but we were looking at Uranus through a distorting lens. Now, the blindfold has been removed. But what exactly was this distorting lens? The illusion of the boring planet is the first myth we must shatter. For decades, scientists believed Uranus had a bizarre, highly asymmetrical magnetic field that was almost entirely depleted of plasma. It made the planet seem inert, dead, and entirely unique in its emptiness. But a recent reanalysis of the Voyager 2 data revealed something shocking. The spacecraft happened to fly by just as a massive solar storm slammed into the planet. This solar wind compressed the magnetic field and blew away the plasma, creating a temporary, anomalous state. We caught Uranus on a very bad day. Imagine taking a photograph of a bustling city right after a massive hurricane has forced everyone indoors, and then assuming the city is always completely empty. That is exactly what we did with Uranus. The solar wind compression squeezed the planet's protective magnetic bubble, forcing it into a shape that scientists could not explain for decades. Now that we understand the context of the solar flare, the pieces of the puzzle are finally snapping together. The ice giant is waking up from its 38-year slumber in our minds. With this new understanding, the true nature of the magnetic field comes into focus. It is not an empty, lifeless void. Without the crushing force of the solar wind, Uranus likely has a magnetosphere teeming with plasma and dynamic energy, much like Jupiter and Saturn. This means the planet is capable of capturing particles from its moons, interacting with the solar wind in complex ways, and generating its own internal electrical currents. The quiet blue sphere is actually humming with invisible power. This leads us to the bizarre orientation of its magnetic field. Most planets, like Earth, have magnetic poles that somewhat align with their axis of rotation. Not Uranus. Its magnetic field is tilted by a staggering 59 degrees away from its spin axis. Furthermore, the magnetic center does not even pass through the core of the planet. It is shifted off-center by a third of the planet's radius. Picture a spinning top, wobbling erratically as it rotates. That is the chaotic nature of the Uranian magnetic field, a swirling mess of invisible lines of force. As we cast our gaze forward from the Voyager era, we meet the ultimate eye in the sky, the James Webb Space Telescope. When Webb turned its golden hexagonal mirrors toward Uranus, it pierced through the veil of time and distance. Webb operates in the infrared spectrum, allowing it to see heat and structure that visible light cameras simply cannot detect. The images it beamed back were nothing short of a revelation. The smooth blue billiard ball was gone. In its place was a luminous, highly textured jewel of the solar system. Let us dispel another common myth right now. Many people believe that Saturn is the only planet graced with rings, but James Webb revealed the Uranian ring system with breathtaking clarity. Unlike Saturn's brilliant rings of reflective water ice, the rings of Uranus are dark, composed of organic molecules and radiation-darkened dust. Yet, in the infrared eyes of Webb, they glowed with a magnificent, ethereal light. We can now clearly see 11 of the 13 known rings, radiating like concentric ripples in a dark cosmic pond. Among these rings lies a ghost, the elusive Zeta ring. It is the innermost ring of Uranus, a faint, diffuse halo of fine dust that is incredibly difficult to spot. For years, it existed mostly in mathematical models and faint, noisy data. But Webb captured it beautifully. Seeing the Zeta ring is like finding a hidden brushstroke on a masterpiece painting. It tells us about the continuous grinding of tiny moonlets and the gravitational dance that keeps this delicate dust in place. The new telescope data also revealed something fascinating about the rings themselves. They have a thermal signature. They are emitting heat. It is a tiny amount of warmth, just fractions of a degree above absolute zero, but it is there. This thermal emission helps scientists understand the composition and density of the ring particles. It paints a picture of a dynamic environment where rocks, ice, and dust are constantly colliding, generating microscopic sparks of heat in the deep freeze of space. Our journey of discovery does not stop with infrared light. Let us shift our vision to the extreme, high-energy realm of X-rays. NASA's Chandra X-ray Observatory recently achieved a milestone, detecting X-ray emissions from Uranus for the very first time. X-rays are usually associated with incredibly violent cosmic events, like black holes or exploding stars. Finding them radiating from a cold, distant ice giant is a profound mystery. It forces us to ask, what unseen fires are burning in this frozen sky? Where are these X-rays coming from? Scientists have two main theories. The first suggests that the rings of Uranus are acting like a giant, dark mirror. They might be scattering X-rays emitted by the sun, bouncing them back into the cosmos for our telescopes to catch. The second theory is even more thrilling. Uranus might be generating its own X-rays through powerful auroras. If true, the planet is acting as a massive particle accelerator, sending electrons crashing into its atmosphere at unimaginable speeds. Speaking of auroras, we now have confirmed evidence of infrared auroras dancing across the Uranian sky. On Earth, auroras are beautiful curtains of green and red light, caused by solar particles colliding with our magnetic field. On Uranus, the process is fundamentally different. Because the magnetic field is a chaotic, tumbling mess, the auroras do not form neat rings at the poles. Instead, they flicker and flare in strange, unpredictable locations across the planet. A silent, invisible light show, finally witnessed by humanity. Beneath these auroras lies an atmosphere that is far from dead. James Webb's imagery revealed striking, bright atmospheric bands circling the planet's equator. We are seeing immense, raging storms and complex cloud structures forming in real time. The wind speeds on Uranus can reach up to 560 miles per hour. It is a dynamic weather system, driven by mechanics we are only just beginning to understand. The pale blue dot is actually a swirling cauldron of gases. To understand the weather, we must address the elephant in the room, the extreme axial tilt. Uranus is the rebel of the solar system. While most planets spin like tops on a table, standing somewhat upright, Uranus rolls along its orbital path like a barrel. It is tilted by 98 degrees. This severe inclination is the defining characteristic of the planet, and it shapes every aspect of its climate, its seasons, and its dramatic atmospheric personality. Because of this extreme tilt, the seasons on Uranus are brutally long and completely alien. A single year on Uranus takes 84 Earth years to complete. This means that for 21 Earth years at a time, one pole is bathed in constant, unrelenting sunlight, while the other pole is plunged into a dark, freezing, multi-decade winter. Imagine a summer that lasts your entire childhood and young adult life, where the sun never, ever sets. That is the reality of the Uranian poles. This continuous sunlight creates a remarkable atmospheric feature known as the polar cap. When Webb observed the sunlit pole, it saw a massive, glowing, swirling cyclone dominating the entire region. As summer approaches the pole, this cap of clouds becomes brighter and more prominent, reflecting the sun's energy. It is a vast vortex of methane ice and ammonia, spinning relentlessly. It is a storm on a planetary scale, a testament to the strange physics of this sideways world. Let us dive deeper, past the cloud tops, into the crushing depths of the ice giant. The term ice giant is actually a bit misleading. It is a myth that Uranus is a solid ball of frozen water. Instead, beneath a thick envelope of hydrogen and helium gas, there is a deep, churning mantle composed of water, ammonia, and methane. Planetary scientists refer to these heavier elements as ices, regardless of their actual physical state. In the depths of Uranus, these ices are a dense, superheated fluid. As we descend further into this fluid mantle, the pressure and temperature reach incomprehensible levels. Here, we encounter one of the most poetic phenomena in the universe: diamond rain. The immense pressure crushes the methane molecules, separating the carbon from the hydrogen. The carbon atoms bond together, forming microscopic diamond crystals. Imagine a slow, silent storm of glittering gems, slowly sinking through a pitch-black ocean of liquid gas. It is a treasure trove that no human will ever touch. Deeper still, the conditions become so extreme that water ceases to act like water. It enters a bizarre phase known as superionic water. In this state, the oxygen atoms lock into a solid crystal lattice, while the hydrogen atoms flow freely through it like a liquid. This black, hot, dense ice is highly conductive to electricity. It is believed that the swirling currents within this superionic ocean are what generate the chaotic, tumbling magnetic field that surrounds the planet. Yet for all this internal activity, Uranus is hiding a dark secret. It is inexplicably cold. It is a common assumption that giant planets generate massive amounts of internal heat, radiating more energy than they receive from the Sun. Jupiter and Neptune certainly do, but Uranus does not. Its internal heat flow is astonishingly low, making it the coldest planetary atmosphere in the solar system, with temperatures plunging to -371 degrees Fahrenheit. Why is the fire out? The lack of internal heat is a puzzle that keeps astronomers awake at night. Some believe that a massive collision in the past scrambled the planet's interior, creating structural barriers that trap the heat deep inside the core, preventing it from rising to the surface. Others suggest that the planet simply formed differently, perhaps with a smaller core or a different composition of materials. It is a quiet, freezing enigma, sitting silently in the dark. But Uranus is not alone in the dark. It is accompanied by a family of 27 known moons, and recent data has brought them into the spotlight. In a beautiful twist of astronomical tradition, these moons are not named after Greek or Roman mythology. Instead, they are named after characters from the works of William Shakespeare and Alexander Pope. Worlds like Miranda, Ariel, Umbriel, Titania, and Oberon. They are a cast of frozen characters performing a slow tragedy in the cosmic theatre. The new reanalysis of Voyager data, combined with advanced computer modeling, has completely revolutionized our view of these moons. For a long time, they were thought to be solid, dead blocks of rock and ice. But the data suggests something miraculous. The four largest moons, Ariel, Umbriel, Titania, and Oberon, likely harbor vast, liquid water oceans beneath their icy crusts. Just like Jupiter's Europa or Saturn's Enceladus, these dark worlds might be hiding warm, watery abysses. Let us take a closer look at Miranda, the strangest of them all. Miranda looks like a moon that was shattered into pieces and hastily glued back together. It features towering ice cliffs, deep canyons, and bizarre grooved terrains called coronae. One cliff, Verona Rupes, is the highest known cliff in the solar system, dropping roughly 12 miles straight down. If you jumped off it, the low gravity would make you fall for 12 minutes before hitting the ground. It is a landscape of pure, tortured chaos. Ariel, another prominent moon, shows signs of recent geological activity. Recent data indicates that Ariel might be actively spewing material onto its surface through cryovolcanism, ice volcanoes erupting in the freezing dark. This activity strongly points to a subsurface ocean that is being kept warm by tidal heating, the gravitational tug-of-war between the moon and the giant plant. Where there is liquid water and heat, scientists cannot help but wonder about the potential for life. The larger moons, Titania and Oberon, act as the icy guardians of the system. They are massive enough to retain internal heat from the radioactive decay of elements in their rocky cores. This internal warmth could be enough to sustain their hidden oceans for billions of years. Imagine a dark, silent sea, trapped between a core of warm rock and a shell of freezing ice, waiting in the absolute dark. It is a humbling thought, expanding the habitable zones of our solar system. But how did this entire system come to be so chaotic? What caused the extreme tilt, the scrambled magnetic field, and the lack of internal heat? The leading theory is violent and cataclysmic. Scientists believe that roughly 4 billion years ago, during the chaotic early days of the solar system, a massive protoplanet, roughly twice the size of Earth, slammed directly into Uranus. It was an impact of unimaginable proportions, a cosmic car crash that changed the planet's destiny forever. This colossal impact literally knocked Uranus onto its side. The debris from the collision eventually settled into the equatorial plane, forming the rings and the moons we see today. It also likely disrupted the deep interior, creating the thermal barriers that trap the planet's heat. The scars of this ancient violence are still visible in every aspect of the Uranian system. It is a beautifully preserved record of a planetary catastrophe. Why is it so crucial that we understand Uranus now? Because it turns out Uranus is the ultimate blueprint for the galaxy. As we discover thousands of exoplanets orbiting distant stars, we are finding that the most common type of planet in the universe, is not a gas giant like Jupiter, and it is not a rocky world like Earth. The most common planets are ice giants, roughly the size of Uranus and Neptune. To understand the galaxy, we must first understand our own sideways neighbor. This brings us to the future. The planetary science community has spoken, and their highest priority for the next decade is clear. We must go back. NASA is actively developing plans for the Uranus Orbiter and Probe mission, a flagship spacecraft designed to slip into orbit around the ice giant and drop a probe directly into its swirling atmosphere. It will be our first dedicated mission to an ice giant, a grand voyage to answer the mysteries that Voyager and Webb have uncovered. The journey will not be easy. It will require a massive rocket, complex gravitational slingshots around other planets, and a flight time that spans more than a decade. It is a mission that requires immense patience and vision, but the reward will be immeasurable. We will finally hear the wind of a new world, we will map the hidden oceans of the Shakespearean moons, and we will unravel the secrets of the magnetic chaos. The pale blue dot is calling to us, inviting us to look closer. As we pull away from Uranus, let the image of this glowing, tilted jewel linger in your mind. We have learned that the universe rarely deals in simple, boring objects. What we once dismissed as a quiet, featureless sphere has revealed itself to be a complex, dynamic symphony of diamond rain, chaotic magnetism, and hidden oceans. It is a testament to the power of human curiosity and the endless wonders that await us when we simply look again with new eyes. We are standing on the precipice of a new era of exploration, ready to journey back to the dark. Thank you for traveling with us through the cold, beautiful expanse of our solar system. If you enjoyed this moment of cosmic tranquility, please leave a like, subscribe for more journeys, and tell us in the comments, would you dare to dive into the icy depths of a Uranian moon? Until next time, keep looking up and let the stars bring you peace.